Hi everyone. Just a quick update of the continuing tests here. I've now reconfigured the wheel to be in rotary motion to better understand and observe the effect. And right now I have 1, 2, 3, 4. Four cores that are identical sizes, and my air gap has been really highly reduced. Let's bring one of these cores here so you can see how tight it is. It's very, very small now. So I haven't hooked up the secondary coils yet to a load or anything like that. I just got the rotary motion going. And what I have is a optical sensor right here that's attached to this, and this here is a timing device that I can adjust the timing on the fly just by turning this with a screwdriver. Actually, I don't have the screwdriver right now. Back and forth, I can adjust the timing forward or ahead or behind. And I've painted this edge here black, and then I've got a strip of just white, well, it's actually reflective tape. This one works better. And this strip here, it represents the 12 volt battery. This is the length of the on time that needs to be to get anywhere close to this is the width of what the 62.5 volt needs on time. So actually I can't make it any smaller than that. It's just micro. And this is, even this whole strip here, I can't even get the RPM that I can get out of this. So I've calculated the joule energy by just doing a capacitive pulse, one single pulse, and calculate the joule amount of energy used, and did that in there. And they're both pretty well the same, but yet this gives you more RPM. So I think what's going on really is this coil here, 12.5 or 12.4 volt DC, is probably not a high enough voltage to get that magnetic field to build up in fast enough time. So I think it's most likely what they call the time constant. So the time constant for this particular coil is not working out with the 12 volt, because it's basically it becomes a pig, and the timing has to be so advanced that this is pretty well where it would go on. There's the opto sensor right there. That's where it would go on. And if we look at the alignment, it has to go on at this point, and this is the point where it shuts off. And on the 62 volt, it is right here where it's on, which is perfect because now it's just pulling. But you know, it can build a magnetic field so much faster with a 62.5 volt, you know, and then just pull that sucker in. And by the time it's just like, you know, pulling it in, it's already shut off at this point here. And it's then the diode that's holding the magnetic field to make it, you know, and it probably dies off at the center here. And then, you know, momentum continues. So that's it. So that's my opto sensor, and then I've got this box here that I've got a good quality heatsink and FET in there, and then I can turn it on and off at will. And then these are the capacitors that I've used for doing a comparison. I use this capacitor here. Actually, it measures out to be much more than 64,000 microfarad. Use that for the 12 volt. And then I use this one here for the 62 volts. So one of these. So the amount of joule energy at 62.5 volts is around like I don't know, somewhere around 6 joules, 6 or 7 joules each. So it's a comparable test for a single pulse. And obviously the 62 volt is working better for this kind of speed that we need. So because, you know, the alignment is better. So I guess that's when voltage needs to be considered. Anyways, just thought I would show you that, and I will have more interesting, hopefully more interesting things to share as I continue this. Thanks. Bye now.